Alright, I'm calling it good. Alright, let me set up our chat so that we can chat to everybody. Let's see. Participants can chat with everyone publicly. Cool. I was like, why am I getting all these direct messages? Alright, chats are set up. Cool. So I hope everybody is doing well and had a good weekend and survived all the snow craziness. I fared well except for a water leak in the middle of the night from the ceiling, but no harm done there. And it's 2:22 time, and we do have about 1 billion things we're going to do today. Is the Linux server down? It can't be down. All right, we're up and running. So let's start with ODPs. So you got some ODPs posted, and 211 is open now. So let me run through this. And then we're going to talk about homework, programming assignment, midterm exam, service learning project, and all kinds of other stuff. All right, ODP 211. This is due tomorrow morning at 10. So you're starting to build up some trees now. Okay, this will be preparation for PA4. So first of all, we're making a structure containing nodes. This is your definition of a node. Again, the order of the things in the node declaration is absolutely critical. So it's got to be an integer followed by 2 pointers to struct T nodes. All right, so put that right in the beginning of your function file. And you're going to make a function called small. It takes 3 integers and it returns a pointer to a T node. And what this function does is it builds a little 3-node tree. So take your 3 integers, call malloc 3 times, allocate enough space for a T node, and for each of those set the data field equal to root left or right. Then set the root up so that its left and right children are the left and right nodes you created, and the left and right children have no nodes. So make them leaf nodes, set their children to null, return the address of the root, and you're good to go. Okay, so this is a particular instance of what we started doing last week more generally, which was building nodes in memory, right, by mallocing space, setting up the fields to have certain values, and connecting these nodes together by having things point to other things. All right, so that's 211. Already got 1 submission with 20 out of 20, so it's doable. Code that up. Test it out if you're not sure. I mean, code it up and assess it and see if it works. If it doesn't work, go ahead and write your own test bed. And, you know, just call this with some interesting values. Don't use zeros, because zeros pop up all the time. But pick some interesting values. Call your small function, and then see what it returns. Look at that inside GDB. And start taking it apart like that. All right. Any questions on that? All right, service learning project. So let me bring out my view of this. So on Canvas, you will find at the bottom Service Learning Project. So you have 2 deliverables left for SLPs. Your final upload is due March 1st. Okay, and we may as well take a look at that while we're in here. There's a template here, and download that. It's like a PowerPoint slide, and fill it in, right? So your upload is a 1-page PDF. Okay, I only need 1 of these per group. But in the template, there's a place in the top for the project name. There's a place for the name of all participants. So fill that in by March 1st, upload it. Okay, and let's eyeball this. I don't know if it'll let me preview it or not. It probably won't. Fun of Canvas. Hey, stuff happening. Alright. I love that the full screen is like the same size as the non-full screen. Alright, so this is your 1-page synopsis, okay? This is something you're going to have for your presentation. This is your elevator pitch. This is the thing that, you know, if you know, you've been working on this for 10 weeks, here's the synopsis of what I've done. Okay, it fits in 1 page. So project title, try to come up with a catchy title that describes what you're doing. Put the date on there. Don't say comma date. Okay. List the name of the team if you've got, you know, multiple people working on this and you have a team name, right? But definitely list the full name of all the team members. No abbreviations, no initials, right? Put your full names on there. And then fill in the following sections as appropriate for your project. Problem definition. Okay, the statement, this is your succinct synopsis of what it is you're working on. It should be more than, you know, a video game. But don't go on, you know, page after page after page. Try to make this concise. Does everybody know what an elevator pitch is? Raise your hand if you know the term elevator pitch. We got some hands going up. All right, you can put your hands down. So at least half the class. Elevator pitch is, you know, you've been working on this idea in the back of your head for, you know, I've got this really cool program that I want to write, and I think everybody would want to buy this, right? And then, you know, one day you're in downtown Portland and you're in some building and you walk into an elevator and in walks, you know, plug in the name of your favorite entrepreneur. So Bill Gates, or, you know, the ghost of Steve Jobs, or Elon Musk, or someone like that. And the doors close and you're in an elevator with this person alone for the next, you know, 25 seconds. What do you say to them, right? Because this person can make your thing happen, right? If you need funding, if you need support from a company or something to make your idea come to life, right? This is the person who could do it for you. You got 25 seconds, though, to tell them what your idea is. So that's an elevator pitch, right? So this is like your elevator pitch here. Okay, what's my thing that I'm trying to do, right? List, you know, what's the scope of this, what's in scope, what's out of scope, what's the approximate schedule, what resources do you need for it, and so on. Competitive analysis, we don't expect you to come up with something that's never been done before, or something which is fundamentally better than everything else out there. That's the dream, right? We don't expect that for your SLP. But you should still look at, you know, other things in the same area. So you're making a side-scrolling video game, right? Well, what are you thinking yours might do that'll be different or better, you know, compared to other side-scrollers out there? Obviously, if you could make a new side-scroller that's fundamentally better than everyone ever made, you're going to be rich, right? But use some imagination here, right? And compare and contrast to, you know, a few of the other things that are out there in the competitive space. Potential applications, I don't know why it says AAA, I think that's left over. But you know, what's this used for? Oh, okay, that means type here. What are you planning to do next quarter, right? Future improvement ideas. And then solution specifications. So this side is basically all your work that you've done so far reduced to half a page. So if you've been, you know, researching your project, you may not have started actually writing anything or building anything, that's fine. But you should have some initial plans, and most of the milestones I saw in the beginning of the term, people had, you know, some kind of goal by the end of this quarter to have something spec'd out, some sort of more detailed description of the system and so on. So that's what goes in here. And again, as much detail as you can, but you want to fit it in half a page. This whole thing is one page, and typically, you know, we print these out and you tape it to the front of your table, and people walking around the room can look at this and get a really good glance at your project, get an idea what you're doing, and then come in and talk to you. What if you put in like 40 hours of work and then switched engines so you have nothing? That definitely happens, and that's part of the goal of this quarter's work is to, you know, make those kinds of discoveries and so on. But, you know, that's not going to affect your problem definition. It's not going to affect your competitive analysis applications or future improvement ideas. It may mean that you don't have a lot for your solution specification, but, you know, if you spent 40 hours on another engine, you probably had some idea on the design of the game. You started trying to put some stuff in. All of that is still part of your solution specification. You hit the go button and, you know, things melted down because there was some fundamental mismatch in capabilities of the engine or something. That's okay, you know, and that goes down under, you know, problem definition, sort of under schedule and resources maybe. But you can still, you know, describe what you were working on and what your plan is for, you know, the final layout of the game and so on and so forth. And yeah, talk about all of that. And this is good stuff, you know, when people come to talk to you one-on-one and ask you questions about your project and so on, that's all stuff you can describe. All right, so that's one of your deliverables, and that is due March 1st by midnight. All right, so upload that as a PDF. Your other deliverable is the presentation. So the presentation is on March 8th, so it's 1 week after that. And so these will obviously be virtual. They'll be done in a Zoom-like setting, but where Izad is setting up basically collaborative spaces where you can go into a breakout room and visitors can come and basically wander from room to room, go in and go out of rooms as they like without having to be invited or assigned to a room. And the setup will be, there'll be roughly 4 people per room, and you'll do rolling presentations, about 5 to 10 minute presentation each, and do your song and dance, right? And people will come in and out of the room as they like. We'll have a list of you know, topics and room numbers available for visitors, and they can say, oh, you know, battery-powered lawnmower, that sounds interesting, you know, and they'll pop into your room and listen to your pitch and maybe ask you questions and things like that. All right, so this will happen March 8th at the regular class time. So for this class, it will be 10 o'clock to 10:50. You have to attend to get credit. Okay, it's one part of your SLP grade. If you can't attend, you get a 0 on this part. There's lots of other parts, and the SLP is a small part of your grade, so don't panic over that. But plan on attending. Okay, it's regular class time. Everyone should be able to do that. Dancing monkeys, yes. We always called them dog and pony shows when I was in the government. Same idea. All right, so that's the basic setup, and if there's multiple people in a group, there's a good chance you'll be in separate rooms, so you each get to do your own presentation, and, you know, potentially have twice as much exposure. So that's good. All right, any questions on SLP, either final deliverable or presentations? Yep, those evil monkey symbols. Why is that always associated with evil? You just know bad things are going to happen when it starts clanging those. There's probably some back.
Darkest 5 that they normally put on these monkeys too.
Oh, Yeah, there's probably some story there, I don't know. All right, good on SLPs. All right, let's go on to programming assignment 3. So let me pull up my notes. Not a whole lot of surprises for you in PA3 because you had a grading rubric. So yeah, and this was pretty much straight out of the assignment. Yep, game was rigged from the start. So yeah, 20 points bonus if you submitted by the original deadline, which almost everybody submitted. So so that was good. People weren't in as dire straits as I thought, or maybe everybody hightailed it to get the bonus points. But either way, most programs were turned in by that early deadline. And it showed up in Canvas as minus 20. That's what my grading software does. But it added 20 points for that. So you got a bump from that. Makefile, no issues that I saw for makefiles. That all seemed to work great. So good stuff there. A few seg faults here and there, and mostly seg faults happened when the stack underflowed or the queue tried to remove something from an empty queue. And that's usually just mismanagement of the linked list. So if you can't figure out where that is, come by office hours and we'll work out the details. Program state, everybody nailed that. So stateful programming, really important concept, and I don't think I saw any issues with that. Printing stacks. So I originally took off points for not indicating where top of the stack head and tail were. I went back and spot checked my lectures, and I decided to give those points back. So if you had an issue where I took off points for that, those points went back. Main program, didn't see any problems. Basic syntax checking requirements, those all seemed to work. Started in stack mode, everybody did that, so that was all great. Valgrind issues, not a whole lot of them, but there were some. So always, anytime you do anything that involves a malloc or anything like that, always run it through Valgrind afterwards, and totally make sure that there's no warnings from Valgrind, and certainly no memory leaks. If you get a warning, then you're setting something up to maybe go wrong later on. Almost no compiler warnings from anybody, so that was good. Good indenting, comments throughout the code. Everybody remembered their name, I think, in the program, so that was good. Comment block before each function. So I'm seeing those. We're going to up the bar on those for PA4. I'm going to give you specific information and formatting that I want for your function comment blocks, because really the goal there is to be able to look and very quickly see, what do I pass to this function, what do I get back from it. And having, a paragraph that describes that, lists all that information, but you have to work through the paragraph to figure out what's the second argument to this function, right? So I'm giving you a specific format for PA4 to document this, and it will make it easier, I think, for you to know that your functions are commented, and have all the pieces to have some kind of standard format for that. So I was super happy with PA3 results. I think everybody did a really good job with this. You've totally got linked lists nailed. Your main programs are working really well. Most people have completely got, making a make file, putting things into Git, naming things consistently, all of that. That's all really good. So just really happy with that, and nice work on PA3. Not a whole lot else I need to say about that. All right, so let's move on to the midterm. And the midterm was also really good. by and large, people nailed this. There was potential for nickel and diming, so some people got kind of nickeled and dimed, right? 2 points here, 3 points there, and now you're down to a B or something, right? Those are kind of a bummer, but I'm not worried about those. Okay, what's concerning is, you know, if you have no idea how to write a conditional statement or how to write a loop, or things like that, right? So certainly getting a very low grade probably indicates there needs to be some kind of course correction to how you're studying, how you're preparing, how you're trying to learn these concepts. But having a lower grade than you would have liked doesn't necessarily mean that you're in that situation. So I tried to give a lot of feedback, and let me just talk about some of the things that I saw. Yeah, raise of pointers to bunny pointers can always be tricky. And I'm not going to do this through Canvas, I'm just going to bring up a copy of the midterm. Let's see. All right, so let's see. So question 1, the bunny structure. So data structure named bunny, which holds 3 integers, a character array, and a pointer named data to a struct node. And those were all kind of red herrings. We didn't do anything with them, but I wanted them to be part of it. Do not write complete C programs, and nobody did. That was good. Just write pieces of code. So write a statement to declare a variable named bun1, which points to a struct bunny. So a declaration is really just naming a variable and saying what type of thing it is. So struct bunny, and is it bun1? Right, something like that. All right, so write a statement to allocate space for a variable bun1 which you declared in part A. So that's your malloc call, right? So bun1 equals malloc. And I think everybody nailed this. Size of struct bunny. Right? So find enough space in the heap for this much stuff and set bun1 to be a pointer to that. So that was awesome. Write some statements to initialize age, year, and time to 0. So that's bun1 arrow age, arrow time, arrow year equals 0. No problems there. All right, part D, declaration for an array of unknown size of struct bunnies named all bunnies. So you want all bunnies to be an array, but you're not specifying what the size of it is. So the only way to do that is like this. Right? Make all bunnies a pointer to a struct bunny. That's what an array is. If you want an array of ints, it's int star all bunnies. If you want an array of doubles, it's double star all bunnies. If you want a string, an array of characters, it's char star all bunnies. If you want an array of struct bunnies, it's struct bunny star all bunnies. It declares an array, but it doesn't say what the size of it is. Now, if you do struct bunny all bunnies bracket 5, you've made an array of 5 bunnies. If you do bracket bracket, you'll get a compile error. The only time we use bracket bracket is when you're passing an argument to a function. You can get away with doing bracket bracket. But you'll never see me write bracket bracket except when I'm saying, you know, some people also do this. Stick with the stars, right? These things are pointers. Let's not try to pretend that there's something magical like an array. Let's just, you know, grit our teeth and say there are no arrays, there's just pointers, right? And embrace the agony. That is C. So that's how you can declare an array of unknown size. And then you want to allocate space for all bunnies, for the all bunnies array. That's a malloc statement, and you need to set aside space for 17. Did I do 17 here? For 1,000 struct bunnies. So all bunnies equals malloc. So size of struct bunny tells you how much space you need for one, multiplied by 1,000 to get space for 1,000. Now all bunnies is pointing to an area that you can treat as an array of 1,000 all bunnies, 1,000 struct bunnies. But it's still just a pointer. Now some people did a double star here and said struct bunny star star all bunnies. That's making all bunnies an array of pointers to struct nodes. Right? That's a valid thing to do, but it's different from what we're trying to do here. This is making an array of struct bunnies. Star star would make an array of pointers to struct bunnies. And if you do that, then in addition to doing this, and this would be malloc 1,000 times the size of a struct bunny star, then you need to go through a loop and 1,000 times initialize each of those struct bunnies to be the size of a struct bunny, if you're asked to do that initialization. It's a pointer to a pointer if you do a star star. Okay, lots of detail there and lots of stuff to write some code, put it inside GDB and look at memory maps, right, and try to get a really good handle on what's going on with these things. Little bit of confusion around that, but I think most people, if you haven't totally nailed this, you're really close to totally nailing this. It's worth going that extra final distance and playing around with, you know, and try it with cars, you know. Do a car star A, do a car star star B. And play around with them in GDB and figure out how to make them do something understandable. All right, question 2 of the linked list. So this is can be really confusing, or you can simplify it by using lots of temporary variables. So list is the address of this node. I could make a node called first and set it equal to list arrow next, and now this node here is called first. And then I could set second equal to first arrow next, and now this node is second, and third equals second arrow next, and now this node is third. And now I don't have to worry about list next, 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 and so on and so forth down here. But we still need to worry about it here. So what is list next, next data? Okay, list next is this block down here in the sentinel node. And list next points to this node. If I do list next, 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 that's this block of this first node, which means it points to this second node. And so if I do list next, next, next data, that's asking for the data field of this node, that's 100. And list next data, just stop one spot earlier, it's -5. So this will print out 100 followed by -5. All right, deleting the last node, 256 from the list. Again, if you set up list first, second, third, it's trivial. Second arrow next equals null, free third. 2 lines of code. And you don't have to think too hard, right? And temporary variables don't allocate memory that we need to free, right? If I say struct node star second, and I set second equal to this, right? I don't need to free that variable unless I'm trying to free this node. So if third is pointing to here, I can say free third, and it'll release this node from memory. But the variable called third, I don't have to worry about that. I just declared that in my C program. It's not being used, it's not using memory from the heap to store the value of that variable. All right. But you can also, you know, do this in a couple of lines. So I could, you know, struct node temp equals list arrow next, arrow next, arrow next. So temp is a pointer to this. And then I could say list arrow next, arrow next, arrow next equals null, which sets this thing to basically be the end of the list. Then I could free my temp variable. And there's different versions of that. Alright, make a new node called new with a data value of 87, no problems there. New equals malloc size of struct node, new arrow data equals 87. And then insert it between the -5 and the 100. So again, if I have a first and a second, new arrow next equals second, first arrow next equals new, and you're done. If not, you can play around with list arrow next, or new arrow next equals list arrow next, and then list arrow next equals new. But make temporary variables. It's never a bad thing. Alright, linked list constructed to store integers. Each node is described. Assume it contains a sentinel. Write a function named sum that takes a pointer to a sentinel, goes through and adds all the positive data fields, and returns that sum. So this is your straightforward list traversal, and the easiest way to do this, and about half the class did this, make it temporary. You don't need a temporary. You could just use the sentinel, but let's make it temporary. Initialize it to your sentinel. So let's just stick with the prototype. So suppose it's sent. So struct node current equals sent arrow next, while current is not null. Look at current data. And this is going to work, right? If you have a sentinel on your linked list, this changes current to be the thing the sentinel points to. If your list is empty, this loop will never iterate. If your list has 5 things, you'll go through this loop 5 times, and each time current will be, I'm not pointing, each time current will be the next node in your list, and after you've processed the last thing in your list, you'll exit the loop. Otherwise, you start getting into possibilities of seg faults, right? If you start off trying to use a node before you check to see if it's null, or possibly counting the sentinel when you shouldn't, or possibly missing the last node when you shouldn't, and so on and so forth. And then inside your loop, just add up things to your running sum if the data is positive, and then return that running sum. I saw a lot of people who wrote things like, if sum equals 0, here, I'll show you what I saw. This works. I didn't take off points for it. But what is this saying? If the sum is 0, let's return 0, which is the sum. Otherwise, return the sum. You could have just said return sum. And you know, if the sum happens to equal 0, it's going to return 0. So, yeah, just return sum. Perfect. But, you know, if you're under a time pressure and this is the way you're thinking of it, do it like that, right? Don't try to make it, you know, more concise just for brownie points, right? If this is the way you're thinking of it, nothing wrong with that, right? But if you're doing this like in an interview question, or you know, if you've got 6 weeks to write this or something like that, right? Never a bad idea to take a step back and look at your code with you know, some sort of fresh eyes, and see if there's things like this that you can tighten up without compromising the integrity of the code, because you always want your code to work. That's sort of like job 1, right? All right, and then the short answer questions. So, so abstract definition of a stack. So what do you do with a stack? You push, you pop, you initialize, you see if it's full, you see if it's empty. Maybe you peek to see what the top of the stack contains. And that's pretty much it, right? What you don't do as an abstract, in interacting with an abstract stack, is look at the length of the underlying array in which the stack is stored. Or look at the stack pointer variable and see if it's equal to the size of the array, or the size of the array minus 1. This thing that's happening in part C, that's makes sense for some implementations of a stack, right? If I implement a stack with a linked list, this is completely meaningless. If I implement my stack with an array and I call my stack pointer stack pointer, this is completely meaningless. If my array length is fixed to be 1,000, this is completely meaningless, right? This is interacting with the underlying mechanics of your stack implementation. That's the antithesis of working with it as an abstract data type. So that's the outlier there. Which of these could potentially cause a seg fault? This is the quintessential seg fault code. Declare a pointer to something and then use the thing that it points to without initializing it, right? Int star x, we don't know what x's value is. We know it points to an integer, but where is it pointing? No idea. Well, go to where that's pointing and read the value there and store it in y. That's asking for a seg fault, right? This is just printing the address of y, and even though x does not have a value, it has an address. When you say int x, the compiler and loader are deciding where to store that. So ampersand x is always well defined. This is just adding 2 integers and storing in a third. That's always seg fault safe. And this is setting y equal to the address of x. And again, that's totally safe. And you can always print the thing that y points to because y has been initialized. It's got the address of x. So this is a fancy way of printing the value of x. All right, allocate enough space for 125 doubles. Everybody did that. A few people wrote double variable bracket 125. That's not what I was looking for, but that does technically allocate space, so that's fine. Utility to help you detect memory leaks. That's Valgrind. Almost everybody got that. Compiling a program named main.c to use GDB. So the least that you needed was this. Right, that gives you an a.out program that you can run through the debugger, so that works fine. A better way would be to name an output file. What you don't want to do, though, is put something in between the -o and the name of the output file, because this says compile a program, call the output file -g. Okay, here's the first program I want you to read and compile. It's called main. Well, main's probably an executable code. It's not going to compile that. And if it actually builds you a file called -g, you're going to have a hard time debugging it because you're going to have to say gdb-g, and that's all kinds of heartache. So either of these is fine, but just remember, if you do -o, always follow it by the name of the file you want created. And the -g could go here, it could go there, it could go at the end. Any of those are fine. Which data structure is known as a LIFO? That's a stack. Last in, first out. Collision handling strategy where one rehashes following a collision, that is chaining. Okay, it is not rehashing. That was a nice attempt. But it's called chaining. Sorry, it's called probing. My bad. So there's two collision strategies we talked about, chaining and probing. Chaining, you basically make a linked list at each node so that if you have a collision, well, you just tack onto the linked list. Probing is where you go back and you keep rehashing. So probe into a location. If that location is in use, rehash. Basically change your probe number, which is an argument to your hash function, and find a new index and keep going. So yeah, that is probing. And then which two statements are true about hashes? Hashes improve efficiency for storing and deleting key pair datas versus parallel arrays because they have this hash function that hopefully gives us order 1 behavior of those operations, so A and C. They do not generally take less space than parallel arrays. In fact, they probably take more space because there's extra information we have to keep, and there's no reason why they need to handle null terminated keys. That's just a total ringer. Most appropriate data structure for customers in a checkout line, that would be a queue, unless this is like, you know, on some game show or something. So, and I think everybody got that. And what's the primary purpose of a hash function? To choose an index in which to store a key, and I think everybody got that. Let's see, sticks is a stack, that's a LIFO, so yeah, it's a stack. And a queue would be a FIFO. All right. My only slightly negative comment on the midterm was that I had a lot of people sending me emails during the exam, sending me chats during the exam or emails right before, saying that, you know, when they type in their code, the first character is getting turned into uppercase. Is that a problem? Right? Yeah, that's a problem. Okay, I didn't take off points for it this time. If someone wrote the number 1, you know, in some cases the whole program had line numbers on it because, you know, their word processor thought they were making an outline. And when they indented, they were labeled A, B, C, and if they indented again, it was Roman numeral 1, 2, 3, right? It's hard to get word processors to do what you want, right? You can use a plain text editor, like, you know, Notepad or Notepad++ or WordPad or Kate or Mousepad or things like that. Some of those will export as PDF. Some of them will let you print to PDF. Some of those you can copy and paste into Google Docs or Word or things like that. But you got to figure out how to do that, right? Which was why I asked you a week ahead of time to practice and make sure you know how to do that so you didn't have to do it on the exam. So please do that before the final, okay? So that you don't, you know, find your code being uppercased or changed or things like that. You can use VI and print from there. You can paste it into a document. Most documents have a way to do verbatim text, which means don't change the formatting, which is exactly what you want, right? But we'll probably do for the final exam the same style exam we did for the midterm, which means I'll post a PDF and you'll create a PDF file with your answers and upload it. So we'll use this mechanism again. So if you had issues with formatting and stuff, practice that and figure that out before the final. And I would say do it now rather than, like, you know, the day before the final. Otherwise you'll forget about it. And yeah, any fixed space font, Courier, anything that says monospace, those are going to look really nice for code because things will line up nicely. Cool. All right, well, this leaves me 4 minutes to talk about PA4, which is not nearly enough time, but let me just mention that PA4 is posted, and we will certainly go through the gory details tomorrow. But this is posted on Canvas now. This will be due a week from Friday at 8 a.m. as usual. Give this a read through. So we're up to 8 pages because I'm trying to specify everything you need to know about the assignment in here. So there's no wiggle room requirement. But basically this is a problem about binary search trees. Okay, so we're going to be working with trees for the next few class sessions. We're going to look at recursive algorithms starting tomorrow. And you're going to read in a database of license plates. Okay, it's a fictitious database I synthesized that you can find in temp database. And there's a sample program, template4, which you can run to see what happens. But basically, you'll type in the name of your program, followed by the name of a database on the command line. It will ingest the information stored in there and save it in a binary search tree. And then the user can interact with the database by either typing in a license plate and the system will respond and show you the owner of that plate, right? So you type in a plate and it tells you the first name and last name. Or you can type in one of two commands. You can say delete followed by a plate, which will remove that plate from the database. Or you can say star dump, which will just give you all kinds of glorious output about your binary search tree. In particular, it will tell you the height of the tree, whether it's balanced, and then it will traverse it in 3 different orders: in order, pre-order, post-order. And for each of those traversals, it will show you 1 line per node containing the plate, followed by the last name, a comma, and a first name. All right. So this is a pretty simple front end to a fairly complex back end, right? So you're going to have to ingest database information, add it to a growing binary search tree, and then have functions for finding the height, whether it's balanced, doing 3 types of traversal, deleting a plate, and looking up a plate. And it's totally doable. You've got everything you need except for the algorithms for doing these things with BSTs, and we'll go through those in the next few days. But there are lots of pieces to this, okay? So as you move on from Clark and you get into, you know, 3rd and 4th year classes, you're going to be working on bigger projects, and they're going to have lots of pieces. And this is largely an exercise in knowing how to attack it, right? And we'll talk about strategies for that. And there's some suggestions in here on how to go about it. But it's an exercise in not getting overwhelmed, right? And not just kind of looking at this and saying, I don't know, and putting it away for a week and a half, and then panicking, right? So knowing how to break it down into small pieces and build it up. And none of the pieces are very bad, right? It's just that there's a lot of them. So yeah, this will be good. Compartmentalizing, exactly. All right, so we'll go through the details of this, but you can look through this document on your own first. So if you have specific questions, we can talk about those. Otherwise, we'll run through this tomorrow, talk about some suggestions for it, go through the grading rubric, and then we'll go back to talking about trees, and we'll start digging into some of these totally awesome recursive functions for manipulating binary search trees. All right, cool. Have a good afternoon, and I will see you tomorrow.